Stan Jabalisco here. I have a radar image centered on Omaha, Nebraska, right in the thick of where some severe weather is taking place right now. So I'd like to take you there from the deep reaches of outer space far above some galaxy, maybe ours, so that we can get a look at the Doppler imagery. Here is Omaha, Nebraska. There is a tornado warning box, that red, well, not box, that sort of irregularly shaped region right there, a tornado warning. Then right here we have severe thunderstorm warning boxes and some more severe thunderstorm warning polygons. Over here, this is where all of the great bulk of activity is taking place. Remember, in a Doppler image like this, the green colors indicate motion of precipitation particles towards the radar and red away from the radar. So notice this little blob of red right here. That's somewhere east of the radar, which is at that little plus sign right there. That, if you have a high resolution display, by the way, I'd recommend you look at it right now. Here's another tornado warning polygon. I didn't even see that one. I'm not sure where the radar for this is, but this is the Omaha-based radar, so that's the data they're getting. Notice the green and the red. Now, when you see green and red come together like that somewhere other than where the radar is, that suggests rotation in the whole system. So let's now look at the composite image, and we can see that right in that same region right there is where the most intense precipitation is taking place, right there. There's also a pretty intense thunderstorm over here, pretty intense one there. That's why these boxes are shaped and positioned the way that they are. This is apparently another severe thunderstorm right there, but this one is really intense. And again, when we look at the velocity storm relative fixed image, we can see that apparent rotation, motion here towards the radar, motion here away from the radar, might suggest, for example, that we are having a counterclockwise circulation like this, somewhere right around in there. Just out of curiosity, I would like to go up and see if I can get the standard version Doppler loop. Now here is the Doppler standard version. We can see pretty much the same data right there. Now let's try and look at a loop instead and see if we can take a look at the evolution of this rotational mess. See how that sort of appears just to the north and east of Omaha, and now it's kind of moving down and kind of curving down a little bit like that. We look at this other one over here. That's pretty near the edge of the radar, so you can't really see much moving in there. But in any case, well, let's see. I guess the center of the radar, the radar center would be right here, not at that plus sign that I showed you, because you can because it's right at the center of this ellipse here, and moreover, that's where these larger red and green meet. We would expect to see precipitation moving generally like this, right around that dot right there. But here, when you see a red blob surrounded by green, or I would presume vice versa, somewhere other than where the radar is, that suggests a tornado or a supercell thunderstorm. So I think we've seen one here. That looks like there very well could be a tornado in progress, or about to be in progress, right in that vicinity. But far out in the deep reaches of space, we don't have to worry about that. We just have to worry about being kind of lonely I mean, being that far away from everything, I don't know. I'm not sure I'm ready to move out there yet. Maybe to the wilderness in Montana, though. Stan Gibilisco signing off. Until next time, so long.